Now, I believe this is where we finished off yesterday, or the next problem that we were going to look at yesterday. Now, when we look at this one here, so we have cosine of arctangent of 1 plus arctangent of x, or arc cosine of x, right as an algebraic expression. So since we're writing it as an algebraic expression, it means we're not really solving for anything. We're not trying to find a value of x. We're going to get an expression. Now to get this here and get the expression that we want, really we're going to end up having to make two triangles. Two different triangles for these here. Because really what we're connecting this to and working this back to is cosine of u plus v. Because this sum and difference formula is just adding or subtracting two angles from each other, dealing with sine, cosine, tangent. And for us here, we're saying that u is equal to arctangent of 1. And we're saying that v is equal to arc cosine of x. Because that's really all we're saying so far. And with trigonometry, probably said this at the first week or when we first started this, is really just the study of triangles. That's why most everything we've been doing, or whenever we try to solve something or come back to something, or not come back to something, just it is always coming back to triangles, because it's the study of triangles. And we can use these triangles here, saying that both of these are right triangles. We can say this is angle U and this is angle V. And the reason we're coming back to this is, well, if we take U is equal to arctangent is really just tangent inverse. What this is also saying is that tangent of angle U is equal to 1. Because when we're trying to find tangent inverse or arctangent of a number, we're really trying to find out what angle, when plugged into tangent, would give us that value. The same thing is true with arc cosine. We're really looking at cosine of V is equal to x. Questions on this so far? Well, tangent of u is equal to 1. Well, tangent's 1 over what? Opposite over adjacent, yes? Well, if it's equal to 1, so we're saying that this side is 1 and this side is 1, yes? Which means the hypotenuse is square root of 2. And it's not too hard to prove it. It's just using Pythagorean's theorem. C squared is equal to 1 squared plus 1 squared. And when we square root, we're saying C is equal to the square root of, well, 1 squared is 1. 1 is the square root of 2. And we also have our special right triangles. Because the only way the two sides are going to be the same is if the angles opposite are the same. So they have to both be 45, which means we're looking at a 45, 45, 90 right triangle. Now the other one, angle V, cosine of V is equal to x. Cosine is the adjacent side over the hypotenuse. So we're calling the adjacent side x, and the hypotenuse would be 1. Now we do need to find the hypotenuse, or not the hypotenuse, but our other side for this triangle, because we're saying x squared plus a squared is equal to 1 squared. We can subtract x squared from both sides, which is really just going to give us 1 minus x squared. We could have said 1 squared minus x squared to keep it as mathematically pure as we can, but 1 squared we know is just 1. And lastly, we would square root both sides, telling us that the other side is the square root of 1 minus x squared. Normally we would put the plus or minus, because anytime we take the square root of both sides, we have to add the plus or minus. But here we're mainly dealing with side lengths, a distance. So this here is the square root of 1 minus x squared. Because here we're talking more in the general sense, not in the actual coordinate planes. And for these here, again, most likely in the text, especially for if these are on the homework assignment, they're going to let us know that the angles are between 0 and 90. They're acute angles, so this would also have to be positive. Any questions on any of this here so far? Okay. Now, if we look back at our formula, so we have cosine of u plus v. Well, this here is the same as cosine of u, cosine of v, minus sine of u, sine of v. So that's just straight from our formulas that we've had so far. And we can fill these in just based off the two triangles that we have. So cosine of u, so if I look at angle u, cosine is adjacent over the hypotenuse, so 1 over the square root of 2. And we can leave it as this here. We can rationalize the denominators later. Let's go on and solve it first before we start messing with that. Now cosine of v. So if we look over here, well, we technically already have it. It's just x. Because we could have used the triangle having x over 1, which is still just x. Minus sine of u, opposite over hypotenuse. So 1 over square root of 2. Which at this point, 1 over the square root of 2 is our square root of 2 over 2, 45 degrees. And our last one, sine of v, opposite over the hypotenuse. So this here is just going to be the square root of 1 minus x squared. Now we can multiply these together. Here and here would be x over the square root of 2 minus. Our ones here are going to be the square root of 1 minus x squared over the square root of 2. More room. Since the denominators are the same, we can subtract the numerators. And last but not least, we can rationalize this denominator by multiplying top and bottom by the square root of 2, which is really just going to give us 2 in the denominator. Because square root of 2 times square root of 2 is the square root of 4, and square root of 4 is just 2. Or we can think of it as the square root of 2 squared. Squared and squared would cancel, again leaving us with 2. Now the numerator we can multiply, so square root of 2 times x is going to be x square root of 2. You can put the x in front or you can put it after it. Either way works. I like putting it in front just so that I can help myself and not accidentally moving that x into the radical. Because it's very easy to do if we're not paying attention. And the way my week's been going, I need to do everything I can to prevent simple mistakes. Now, the other one, when we multiply the square root of 2 by the square root of 1 minus x squared. They're both radicals, yes? So we can multiply what's inside. So what we have is the square root of, well, 2 times 1 is 2. 2 times x squared is going to be 2x squared. And that's it there. Questions on any of this here? Any questions on this so far? So this here really isn't that bad. Most of it is really just setting up the triangles, plugging in and simplifying. We could have saved this step with multiplying by the square root of 2 over the square root of 2. If instead of plugging in 1 over the square root of 2, we'd plugged in square root of 2 over 2. Might have saved us a little bit there, but that's about it yet. Questions on any of this here? Yep. We can look at one more of these here. And whenever I look at these, I'm going to always start here, sine of u plus v. Where we have u being arc, u is, we can say, tangent inverse of 1, and v is cosine inverse of x. Well, looking at this here, this problem's a little bit nice in that we're still using tangent inverse for u and cosine inverse for v. So it means over here for our triangle with u, tangent opposite over adjacent. It's going to be 1 over 1, which again means the hypotenuse is square root of 2. And for v, cosine inverse is going to be adjacent over the hypotenuse. And as we already found, that the other side is going to be 1 minus x squared. If we already have it, there's no reason to reprove it or re-show that it works. Now, sine of u plus v is going to be sine of u cosine v plus cosine u sine of v. And now we just need to plug these in. Now, sine of u, well, that's 1 over the square root of 2. This time we can simplify it, because 1 over the square root of 2 will simplify to the square root of 2 over 2. And again, any of these here, especially with 1 over the square root of 2, where we just have numbers, we don't have the variable, the 30xs will simplify for us. We can plug 1 over the square root of 2 as a fraction, hit enter, and it'll tell us it's the square root of 2 over 2. Cosine of v. Cosine of v is going to be adjacent over the hypotenuse, which is still just x, plus cosine of u, 1 over the square root of 2, which is square root of 2 over 2. And sine of v is the square root of 1 minus x squared over 1, which is going to be the square root of 1 minus x squared. Questions on how we set this up? Well, now we can multiply these together. which is going to give us x square root of 2 over 2, plus, we're going to have a denominator of 2, since we have the square root of 2 times the square root of 1 minus x squared. Again, we can multiply inside the radicals. So 2 times 1 is 2, minus 2x squared. Since the denominators are the same, we can add the numerators. And since our two radicals are not the exact same, we can't add them together. So this here is the final answer. Questions on any of this here? You don't have to write this down, just kind of follow along with me, because again, I said that we weren't really going to do any more of these proofs or verifying that both sides are true. I want to show this to you so that y'all have seen it. You don't have to write it down. I'm not going to make you do these, especially on the assignment. Now, what we're trying to show is that cosine of pi minus x is the same as sine of x. This is one of our cofunctions. Now, for this here, the difference with cosine is really telling us that we have cosine of pi over 2 times cosine of x plus sine of pi over 2 times sine of x. Now, when we look at this here, cosine of pi over 2 is 0. So we have 0 times cosine of x, because cosine of x is straight up, and that is 0, because it's the x value. Now, sine is the y value going straight up, so it is 1. Well, 0 times cosine is 0. It's gone. 1 times sine is just, so cosine of pi over 2 minus x is the same as sine of x. And we use this a lot, especially in geometry. You may not think of it as this way, because pi over 2 in degrees is 90. Cosine of 90 minus x is the same as sine of x. So that's all we're looking at there. Okay, this next one here is express as a trig function of only theta. That means we want to get rid of any cosine, sine, tangent function that has a number other than theta. So if it actually has an angle, we want to get rid of it. And we can do this by applying our sum and different properties. So cosine of theta minus 3 pi over 2, looking at u minus v, would be cosine of theta times cosine of 3 pi over 2 plus sine of theta times sine of 3 pi over 2. Now 3 pi over 2 is a nice angle because it's straight down. It's 270. And that may or may not be easy or kind of difficult for y'all to remember. But if we think of the unit circle, it's broken up into 4 quadrants, yes? So the x-axis, positive x-axis is 0. Straight up, we have 1, 2, 3, and then back to 4, yes? So 0, all the way on the negative x-axis would be 1. So in the middle is half. So we have 0, 1/2, 1, 1.5, and back to 2. And 3/2 is 1.5. So we're looking straight down on the unit circle. You don't have to memorize that because the unit circle will give you these here. And at this one here, we have 0, -1 as our point, which means cosine of 3 pi over 2 is 0. Well, we have sine of theta, and sine of 3 pi over 2 is negative 1. Well, this is 0, giving us negative sine of theta. Now we have an expression in only terms of theta. Questions on this here? We're ready for another one like this. Tangent of theta plus 3 pi, express as only theta. And again, we're going just back to the formulas. We're going back to the formulas. And for this here, we're going to have tangent of theta plus tangent of 3 pi over 1 minus tangent of theta tangent of 3 pi. And again, I'm not expecting y'all to memorize these, because I will probably have most of these pretty much down by the time we hit the test next week, but then not 2 months later, they are all gone. So again, especially on the test, review, homework, be referring back to that reference sheet and looking at them. Because as we saw yesterday, it's very easy, even for me, to flip the angles or to change the signs. Because a lot of these formulas, the only real difference is the sign change. Because if we were looking at tangent of theta minus 3 pi, the sign on top would be negative, the sign on bottom would be positive, the rest of it would be about the same. But again, that small sign change will change the answer. So again, it's good to make sure. Now with this here, we'll have tangent of theta plus 3 pi. Well, all the way around is 2 pi. We got to go one more. So we were over on the right here would be 3 pi, which is the point -1, 0, which for tangent is sine over cosine, which means tangent of 3 pi is 0. Either calculator would have given that to us also, as long as it's in radians, not degrees. On bottom, we have 1 minus tangent of theta times 0. This is not going to be 0. Because if we look at the numerator, tangent of theta plus 0 is just tangent of theta, yes? Over. Well, this whole part here is going to become 0. 1 minus 0 is 1, which is just tangent of theta. Some of these here will work out nicely, some of them won't. And when I say nicely, we don't get just a term, like the last two that we've got. Any other questions on any of this here? Any questions on anything we've done so far? We feel good with this here? So I'm going to skip over this one. I want to look at this one here, because this one here is one of the ones I would say is not nice, quote unquote, not nice, because when we look at the formula, we'll have tangent of theta minus, and again, I'm going to reference back and make sure, yes, minus tangent of pi over 4 over 1 plus tangent of theta times tangent of pi over 4. So again, we're just plugging these into the formula. for u and v, because u is going to be theta and v is going to be pi over 4. So we'll still have tangent of theta minus 1 plus tangent of theta. Pi over 4 on the unit circle gives us a coordinate point of square root 2 over 2 comma square root 2 over 2. And for tangent, that's going to give us 1. And it is on our unit circle. I did also provide it at the bottom in that little box that we had for pi over 4. It gave it to us as 1. Okay. Now we can do some simplifying a little bit on top. Well, I can drop the parentheses and say tangent of theta minus 1. On bottom, we'll have 1 plus tangent of theta. And at this point here, it feels like we need to do something else, yes? Because we have this fraction. But what did the instructions say? Express as a trig function of only theta, yes? Do any of the trig functions have something other than theta inside of them? Well, no, because the top one, the only one that we have is tangent of theta. The bottom, we only have tangent of theta. That is the answer. And that's what I meant by some of these aren't nice. Because the two that we've done were kind of nice. We ended up with tangent of theta, or just negative sine of theta. We just end up with a term without a fraction. Here, it doesn't look as quote-unquote nice, because we have 1 minus, or tangent of theta minus 1 over 1 plus tangent of theta. It just doesn't look nice. But this is the final answer. That's all we have to do. We just have to get rid of any trig function that doesn't have theta inside of it. But that's it. Questions on this here? Solving is the last thing we're doing. We're doing 2 of these where we're solving for x. Find all the solutions of sine of x plus pi over 4 plus sine of x minus pi over 4 equals negative 1. And again, there's nothing preventing us from typing this into the calculator. So on the calculator, we get y equals sine of x plus alpha y equals enter pi over 4 plus sine of x minus alpha y equals enter second pi over 4 is what we had on the one side, yes? So I'm going to show you this here, and then I'll show you the other way we can type it in. Negative 1, because that was on the other side of the equation, yes? Graph. We have this here, and we have this line, yes? So if we did it this way, we're trying to see where those two intersect, where those two have the same value, between 0 and 2 pi. Now, luckily, our graph is on the unit, or 2 pi will be visible, so right there is where we're looking. So between 0 and 2 pi, we have exactly 2 places where it does cross, 2 places where it intersects the graph that we'd be looking at. Now, again, the other way we could have done this is added 1 to both sides, got it equal to 0. Again, we have 2 places that it intersects. And we could have found intersection or zeros. 0, number 2, 5 is intersection. We could use those to approximate or find the value. And we do this, I can do a left bound and a right bound. Really what this is saying, I'm making 2 endpoints and telling the calculator somewhere between these 2 spots, it crosses the x-axis. And luckily for us, we know exactly what 3.9269908 is. Oh, I have no idea what that is off the top of my head. So it'd have been nice if it was something like 1/2, because if it was, we know that's going to be an angle of pi over 2. Or if it was one or a number times 1.5, then we could go from there. But unfortunately, it doesn't give it to us in terms of pi because, well, it'd be pi over 2, which would be 3.14, so 1.07 going on. And I mean, we could try approximating different angles that are nice on the unit circle with pi and trying to match them up. But at that point, I feel like we're putting more work into trying to figure out what that decimal approximation is than we could have just figured it out using the actual steps. So, we're ready to solve this here. Well, we know for certain we're going to have how many answers? 2, because we saw it cross the graph twice. Now, I'm going to do 2 things at once. Well, we could actually say 3. One of those is going to be applying our sum and difference for sine of our angle. So let's look at this here. So sine of x plus pi over 4. So this here would be our sine of x cosine of pi over 4 plus cosine of x sine of pi over 4. Because that's our first one. Plus the other one is going to be sine of x cosine of pi over 4 minus cosine of x sine of pi over 4. All right. So, any questions on this so far? Wrong one. Now, so far we've only really done 2 things, yes? And I said we would be doing 3. Well, when we're solving all of these or any equation, we've always set this equal to what? 0, yes? So the other thing we could do is just add 1 to both sides and make it be 0. Now, looking at all this here, we can simplify a little bit. Because one of the things we know is that cosine of pi over 4 and sine of pi over 4, all of these here are going to be square root 2 over 2. So what we had is the square root of 2 over 2 sine of x plus square root 2 over 2 cosine of x plus here we're going to have square root of 2 over 2 sine of x minus square root of 2 over 2 cosine of x plus 1 is equal to 0. Well, that's nice and all, but now we have sine and cosine. We don't have any that are squared, so it's kind of unfortunate because we can't use Pythagorean identities. But there is something nice. Because one of the cosines we have is a positive square root 2 over 2. The other one is a negative. These two here are going to combine to become 0. So both of those are gone. We can add the other 2, which will give us sine of x, yes? Plus 1. Now, square root of 2 over 2 plus square root of 2 over 2 would be what? So let's remove the square root of 2 and just say it's 1. What do I have instead? 1/2 plus 1/2. And what's 1/2 plus 1/2? 1. So square root of 2 over 2 plus square root of 2 over 2 is just the square root of 2. And again, that works with most things. Because we're adding those together, we have 2 of them. So it's going to be, the denominator is going to simplify. Or we could have said that we have 2 square roots of 2 over 2. The 2 and 2 would simplify, just leaving us with the square root of 2. Well, unfortunately, I have to move the 1 back over. Because since we only have sine of x, we only have one term, we can just get it by itself and solve. And divide by the square root of 2, telling us sine of x is equal to negative square root of 2 over 2. Questions on this here? Now what that's going to tell us is that x is equal to, let's see here, 5 pi over 4 and 7 pi over 4. Part of the reason I hold that out so quick is whenever we're dealing with square root 2 over 2, it's our 45s, or pi over 4, so the denominator has to be 4. Sine is negative in the third and fourth quadrant. So I can, from 2 pi, we can subtract pi over 4, subtract 1/4 from 2. 2 would be 8/4, take 1 away, 7/4. Second, or the third quadrant, we're adding pi over 4 to pi. So 4 over 4 plus 1/4 is going to give us 5/4. And those are our two answers. Any questions on any of this here? We feel pretty comfortable with this? You don't want to see one more? Let's look at one more. This will be the last one here that we look at, and it'll go hopefully a little bit quicker, because hopefully I won't have any interruptions. Now, when we do this one here, we can start off with our sum and difference formulas. So sine of x cosine of pi over 2 plus cosine of x sine of pi over 2 plus our next one would be sine of x cosine of 3 pi over 2 minus cosine of x sine of 3 pi over 2 is equal to 1. I'm going to leave the 1 over there just based off the last one where we ended up with just a single trig function, hoping for the same thing here. Now sine of pi over 2, or cosine of pi over 2 here, so that is going straight up, and cosine is 0. So we have 0 times sine of x plus sine of pi over 2 is 1. So we have 1 times cosine of x plus cosine of 3 pi over 2. 3 pi over 2 is straight down for us, so it is 0 sine of x minus, well, three pi over 2 for sine is going to be negative 1. And again, we just got these values for each one of these here from the unit circle, or we could have plugged it into the calculator. Either one would work. Any questions on any of this here? Well, that's gone. That one's gone. Which really just tells us cosine of x. So here we'd have negative cosine of x, which would just be plus cosine of x is equal to 1. Well, cosine of x plus cosine of x is 2. Cosine of x is equal to 1. Which means last but not least, we can divide by 2, telling us cosine of x is 1/2. Now at this point here, we can look at the unit circle to see where cosine is 1/2, or take cosine inverse to determine where it's 1/2, which is going to be pi over 3 or 5 pi over 3. And that's it. Questions on this here? Hopefully these weren't as bad as you guys thought they were going to be, especially with these theorems, but that is the end of that there.